Every calorie you consume, you conserve, because I come from a very cold climate. For my wife, eat 3 times as much and you never put on any weight. It's all hidden in this code, and it's starting to be understood at breakneck pace. So what can we do with genomes now that we can read them, now that we're starting to have the book of life? Well, there's many things. Some are exciting, some people will find very scary. I will tell you a couple of things that will probably make you want to projectile puke on me, but that's okay. So, we now can learn the history of organisms. You can do a very simple test, scrape your cheek, send it off. You can find out where your relatives come from. You can do your genealogy going back thousands of years. We can understand functionality. This is really important. We can understand, for example, why we create plaque in our arteries, what creates the starchiness inside of a grain, why does yeast metabolize sugar and produce carbon dioxide. We can also look at a grander scale, what creates problems, what creates disease, and how we may be able to fix them. Because we can understand this, we can fix them, make better organisms. Most importantly, what we're learning is that nature has provided us a spectacular toolbox. The toolbox exists. An architect far better and smarter than us has given us that toolbox, and we now have the ability to use it. We are now not just reading genomes, we are writing them. This company, Synthetic Genomics, I'm involved with, created the first full synthetic genome for a little bug, a very primitive creature called Mycoplasma genitalium. If you have a UTI, you've probably, or ever had a UTI, you've come in contact with this little bug. Very simple, only has about 246 genes, but we were able to completely synthesize that genome. Now you have the genome and you say to yourself, so if I plug this synthetic genome, if I pull the old one out and plug it in, does it just boot up and live? Well, guess what? It does. Not only does it do that, if you took the genome, that synthetic genome, and you plugged it into a different critter like yeast, you now turn that yeast into mycoplasma. It's sort of like booting up a PC with a Mac OS software. Well, actually, you could do it the other way. So, by being able to write a genome and plug it into an organism, the software, if you will, changes the hardware. And this is extremely profound. So, last year, the French and Italians announced they got together and they went ahead and they sequenced Pinot Noir. The genomic sequence now exists for the entire Pinot Noir organism. They identified, once again, about 29,000 genes. They have discovered pathways that create flavors, although it's very important to understand that those compounds that it's cranking out have to match a receptor in our genome and in our tongue for us to understand and interpret those flavors. They've also discovered that there's a heck of a lot of activity going on producing aroma as well. They've identified areas of vulnerability to disease. They now are understanding, and the work is going on, exactly how this plant works, and we have the capability to know, to read that entire code and understand how it ticks. So then what do? Knowing we can read it, knowing that we can write it, change it, maybe write its genome from scratch. So what do? Well, one thing you could do is what some people might call Franken-Noir. We can build a better vine. By the way, just so you know, you get stressed out about genetically modified organisms. There is not one single vine in this valley or anywhere that is not genetically modified. They're not grown from seeds. They're grafted into rootstock. They would not exist in nature on their own. So don't stress about that stuff. We've been doing this forever. So we could, focus on disease resistance. We can go for higher yields without necessarily having dramatic farming techniques to do it or cost. We could conceivably expand the climate window. We could make Pinot Noir grow maybe in Long Island, God forbid. We could produce better flavors and aromas. You want a little more raspberry, a little more chocolate here or there. All of these things could conceivably be done, and I will tell you, I'd pretty much bet that it will be done. But there's an ecosystem here. In other words, we're not sort of unique little organisms running around. We are part of a big ecosystem. In fact, I'm sorry to inform you that inside of your digestive tract is about 10 pounds of microbes, which are circulating through your body quite a bit. Our ocean's teeming with microbes. In fact, when Craig Venter went and sequenced the microbes